For that, show IP interface brief, nothing. Yeah, here also nothing. Before this, first we need to create VRFs. What is the command? IP VRF. Then what is the name of the VRF? Right. So let me give it VRF1. And immediately I will be entering into VRF configuration mode. Clear? Get out from there. We have nothing to do here. Right. Now I have created VRF. Interface loopback 1. It is 1.1.1.1 255. I created and see if I create one more loopback here from the same network 1.1.1.2 255.255.255.0. Can you see this? 1.1.1.0 overlaps with loopback 1. Why? Because both of them, whatever we are making entry here, these are directly entering into global routing table. And if you see now, one dot one dot one dot one has entered into global routing table, show IP route. Here, that is why it is not allowing. I will make them part of VRFs and then we will see. How will you make an interface part of VRF? With the command IP VRF forwarding and then VRF name. VRF1. Here. And remember, whenever you are making an interface part of VRF, whatever the pre-configuration you have, IP addresses and everything will be removed. And it will be a fresh interface now. And now say do show IP route. I have nothing. My interface has been removed. Why? Because I have made it part of VRF1. And now I should have IP address. I should add IP address. 1.1.1.1. Done. Interface loopback to VRF forwarding. Sorry, I need to create one more VRF here. VRF2. Interface loopback to forwarding VRF2. Here, show IP route, no entry. We are checking the routing table, global routing table, but we have made them part of different VRFs. So what should we do? Show IP route VRF, VRF name, VRF1. And in the VRF1 routing table, you can see 1.1.1.1. VRF2, I think we didn't give any address on that. Look back to 1.1.1.2. Can you see, though I have given the IP address, it is not telling me any errors. VRF2 and here disable it. Both are belong to same network. Still, I have no error. Why? Because now they are part of two different VRFs, two different routing tables. Getting it the logic? Yeah. The same thing on R2 also. I have created VRF1. Here also on R2, we have formed two different VRFs, VRF1 and VRF2, right? Now, how do I extend between these two routers? For that, I will use Ethernet 0x0. Interface is 0x0. But here I'm having two different VRFs. For two different VRFs, I have to form, as I'm having a single network, single interface here. Let me think I'm having a single interface, that is E0x0, Ethernet network, Ethernet link. Then I have to form sub-interfaces to differentiate between two different VRFs. For that, let me create loopbacks. Sorry, A0x0.1. VRF forwarding VRF1. Encapsulation.1q for VLAN 1. And now I am adding address 21.1. Is 0x0.2. VRF2. VLAN 2. And if you remember, I'm giving the same IP on both the logical interfaces, and it is not showing any error. On logical interface, on subinterface E0x0.2, I have given the same IP 12.1, and even on E0x0.1 also I have given the same IP address. No shit. Here. Now on R2. For VLAN 2. Now say show can you say this for VRF1 and for VRF2? Same thing here. We are having the same network on two different VRFs, right? Yeah. And now how do you add a static route? IP route, VRF name, and what is the prefix? 2.2.2.0 and 12. Same thing for VRF2. And you can see the entries here. Static entries has been maintained, right? Same thing for VRF2. Here. Now. Packets. And from R2, if I ping directly 1.1.1.1, it will not be able to ping. Why? Because when you are giving the ping, our router will go and check directly the global routing table for 1.1.1.1. Here there is no 1.1.1.1. So whenever you are doing the ping, you have to mention from which VRF. VRF1. What is the IP? 1.1.1.1. Now it is able to ping. You see on here. I think fortunately we cannot see to which routing table we received it. We have received it on Ethernet 0x0.1. Here VRF1 member. And if I try to ping, then 1.1.1.2, no such packet. It has failed. Yeah. So this is how you will create VRF. The command to check the IP route VRF routing table is show IP route VRF and the VRF name. And how do you show running configuration? Section VRF. First, you need to create VRFs. Then you need to make interfaces part of those VRFs, right? And in between, if you want to form between two routers and if you're having a single interface between them, then you need to form sub-interfaces and make them part of VRFs. Right? This is how the communication will be possible between two VRFs. Right? And my routing table is completely maintained different. And remember, whenever you're creating VRFs, Ceph will be divided. That is why one routing table cannot communicate with another routing table. Clear? And if you want to run any routing protocols between them, router rip, if you are giving here directly the command network, it will be picking up the networks from global routing table. But you want to run these for VRFs, then first you need to tell IPv4 VRF, which VRF this is to be part of. And what is that name? VRF1. And immediately it will enter into that address family. And now you need to give the command network 1.1.1.0. Network 12.0.0.0. Yep. Here also the same thing. Router RIP. Address family. IPv4. VRF. VRF 1. 2.2.2.0. Show IP route. VRF 1. And my network is learned via VRF. Sorry, RIP. Here. Remember, if you are directly giving the network command, it will be applied for the global routing table, but I want it to be running for the VRF. For that, oh, sorry. Yeah, you can see here, RIP. And first I need to get into the address family with which I can tell to which VRF should this be run. And then I need to give the command then I need to give the command network command. Clear? Yes. The same case with EIGRP also. Address family, IPv4, unicast, VRF. What is a VRF? VRF 2. And then I need to tell complete another autonomous system number. 12. Sorry, yeah. Autonomous system number 12. And now I have to give the command 1.1.1.0. Network 12.0.0.0. Here too, I have a static entry. Let me remove that. There, and I will enable the same thing here on this router. For VRF2, autonomous system number 12. Oh, autonomous system number 12. HRB router ID, let me give it as 1.1.1.1. Right, so I'm giving now I think it should form the neighborship. VRF1 neighbors. Sorry, VRF2. You can see this how this is how we enable EIGRP for VRF, right? First, you need to the same command as we did for RIP. First, you need to enter into EIGRP. Then you need to give the address family IPv4. Since you have to tell to which VRF this EIGRP has to be run. Then autonomous system number. Then the networks. Clear? The same thing here. You need to mention to which address family should this be running. And then as usual, network command. Clear? Understood? Right. With this, your VRF will be finishing, right? And now we'll be starting with GRE, right? GRE VPN. Before that, let me just reset all this. Right. GRE generic routing encapsulation, right? This is a VPN technology. Right, and this GRE protocol uses protocol number 47. Here, this is generally used when you want to form a virtual tunnel between two different sites. Whatever the distance it could be different, whatever the distance it could be between these two sites, you can form a tunnel between these two sites. And in order to form this GRE, in order to use this GRE, you should have an internet connectivity. Right? And remember how this actually happens is you will be creating tunnel interface on both the routers. You will be creating a separate logical interface tunnel and tunnel number, right? And you will be giving IP address on this private IP address, whatever you want. You can give an IP address, subnet mask, right? And remember, whatever the routing protocols you are running between these two routers in order to exchange the routing information, this IP will be used here. And then you will be defining tunnel source and the destination. And the tunnel source and tunnel destination will be the public IP addresses of your sites. Clear? First thing is you will create tunnel between two routers. How do you create a tunnel? Tunnel is nothing but just an interface tunnel, right? And to that you will be giving an IP address, private IP address, and then you need to define tunnel source and destination, where the source and destination are the public IP addresses of your sites, and which tells that tunnel will start from this IP and it will end at this IP. Clear? And then you can run routing on these tunnels. Right? Remember, whenever you are creating a tunnel, your tunnel interface will come up only when our router has route to this destination, tunnel destination. If it has somehow, whether it is through static route or whether it is RIP route, EHRP route, whatever it could be, it should have the route to reachability to this destination IP of this tunnel. Then only this interface will come up. If not, it will always be down. Clear? And the same way you have to define on R2 also. You have to create a tunnel and you need to define an IP address. You need to define a tunnel source and then tunnel destination. And how this will work? I'm having through connectivity through the internet. And let me suppose here I'm using 24 network. /24 network, right? In order to make this private network reachable via the internet, such that this PC here with 10.0.0.1 can directly access or ping this 20.0.0.1, right? In order to do that, first I need to form a tunnel over interface over internet like this, right? And here I will mention interface tunnel 0. I will give some IP address, whatever it could be, right? And then I need to mention tunnel source. The tunnel source should always be the public IP of this thing. So let me think I'm using some public network. (21.1) is the source. Tunnel destination is 21.2. Here, this can be of same network or this can be some other thing, right? And even I can give some other thing like this: 193.162.21.2, right? And that's it. And here on this interface, on this router, I am also creating a tunnel. Interface tunnel 0. Tunnel source is 193.162.21.2. Tunnel destination is 21.1. Remember, tunnel source and destination must be matching. Yep. As soon as I have made these entries, our routers will create tunnel interfaces on their routers, on them, right? And from now, whether I'm running static routing, RIP, EHRP, OSPF, whatever it could be, I will be doing based on these IP addresses. 12.1, 12.2. Clear? And what happens, whatever the routes our routers are learning, now whenever I have given this command, I am giving it on IP route R1 20.0.0.0, tunnel 0, right? As soon as I have given this command, our router will make an entry in its routing table. And how will it do it? whether it is static, if it is static, 20.0.0.0.0/24 1/0 via tunnel 0. And I'm also learning some routes from internet. And let me think that I'm learning a default route. Via 21.2 is my ISP IP address. Right? Now, I have generated a packet from 10.1. It is an ICMP packet. Source is 10.1. Destination is 20.1. As soon as my router receives this packet, it will check. Yes, 20.1 is having. What is the exit interface? It is tunnel 0. Then immediately on this, it will make a GRE, it will add a GRE header, and over that GRE header, it will add one more header. Source of this packet is tunnel source 21.1. So destination of this is 193.162.21.2. Now, whatever the internet routers, whatever the number of routers in the internet, they will see this packet. They will only be checking this outer external IP header added by GRE. And they will be routing it to the 21.2. Now, here is the public IP. 21.2 has received it. He will check, yes, this is for me. From 21.1. He will remove this and he will find in the IP header of this protocol number is 47. He'll identify, this is for GRE. This means that I have some other IP header in it. He will completely decapsulate this and he will check. This is for 20.1. Do I have 20.1 connected to me? Yes, I have it. This is directly connected to me. And he will forward that packet to 20.1. And if I am sending from 10.1 to ISP, to Google 8.8.8.8, HTTP layer 4 header. Then 10.1 is my source. Destination is 8.8.8.8. My R1 has received this and he will check 8.8.8.8. It is not matching, but default route is matching. From whom? 21.2. He will not encapsulate this anything. If NATing is performed on R1, he will perform NATing on the source to the public IP address of this R1 and he will directly forward it to internet. Remember, whenever tunnel GRE, you are doing GRE, if our router sees that exit interface as tunnel 0, he will encapsulate GRE. Other than that, he will be directly performing it. If NAT is performed, NAT according to NAT is performed, and it will be sent out to the ISP. Here, this is a GRE tunnel, right? And this is a normal GRE point to point, or else called as point to point. When are you calling this as a point to point? If on routers, if you are mentioning tunnel, both the tunnel source and destination, then it is a point to point GRE tunnel, right? But if from a single hub over the internet, if you want to get the access through the single tunnel, if you want to connect to multiple spokes, spoke 1, spoke 2, spoke 3, then you will use GRE multi-hop tunnel. Sorry, at multi-point tunnel. Clear? And in this, you will not mention tunnel destination, but you will perform only, but you will tell only the tunnel source. Now, how the routing will be done if no tunnel destination is given, right? The spokes and hub, they will use one protocol called NHRP, Next Hop Resolution Protocol. This protocol between hub and spoke will communicate some information, and from spoke to hub, it will send the information tunnel IP, which is a private IP of this spoke. In order to go to this tunnel destination, what is the public IP should be used? This information is sent by spoke to hub. And in order for acknowledgement, hub will send the same message to spoke. When spoke receives the same message, he sent to hub. He will make sure that yes, I have registered. My registration is confirmed at the hub. And whenever hub receives this message, registration message, NHRP registration message, he will make an entry in his NHRP table that so and so tunnel IP, in order to reach this tunnel destination should be this particular IP, public IP. Clear? This is NHRP, right? And this is called phase 1. Now phase 2 is, in this phase 1, spoke 1 cannot communicate with spoke 2. It can only communicate with the hub. Now if you want connectivity between spoke 1 and spoke 2, then we need to form phase 2 GRE tunnel. And in the phase 2 GRE tunnel, what happens? Even the spokes, they will have multi-point GRE tunnel. In the phase 1, only hub was having the GRE multi-point tunnel, and spokes were having point to point. Why? Because on the spokes, you will define what is a tunnel source and destination, but on the hub, you will not. But in the phase 2, even on the spokes, you will define it as GRE multi-point tunnel. Clear? And in the phase 3, you have some enhancements to the routings. Right? What happened in the phase 2? In phase 1, only he can communicate with hub. If he wants to speak to spoke 2, he cannot. Whereas in phase 2, if he wants to, he can speak to spoke 2. But all the traffic was going all the way around the hub, and from hub it is going to spoke 2. And even from spoke 3, it will go for hub and hub to spoke 2. Okay? But whereas in phase 3, there will be a direct communication between the spokes. Right? So this is GRE, right? And let us see a small example, a small practical of this. Now, in this topology, I will here be creating a loopback on R5 5.5.5.5. And here I will be creating a loopback 2.2.2.2. I will be using an IP here. Let me think it as public IP. Right? What public IP I will be using here? 193.162.15.5, and here 193.162.15.1, and here 193.162.12.1, 193.162.12. And I will form the GRE tunnel between these R1 to R2 through the R1. Clear? And I will do static routing via these interfaces tunnel, such that R1 will not have any information of 2.2.2.2, 5.5.5.5, my private networks, even though there will be a communication between the loopbacks. How I'll create a tunnel here. Clear? I'll create a point to point, and you can see here now how can we do it. First, on R1, here, and now interface tunnel 0, and having some IP address here. Let me between 25.5, 55.55.55.0. Remember, tunnel IP addresses must be in the same network. Why? Because based on tunnel interface, all the routing protocol neighborships will be done. So you have to have the same network. And I will mention tunnel source as my public IP. Why? Because the complete routing over the internet is done via tunnel, right? So the tunnel source and destination must be a public network. .12.2. Though I have given this, oh, it has come up. Why do we have any route? Yeah, we are forming it on R1. So that is where it is formed. Let us make it on R5. Interface tunnel 0. Tunnel source 193.162. My interface, tunnel interface is down. Do show IP interface. Now even my line protocol is down. Though my administrative status is up, it is still down. Why? Because whatever the destination I have given here, my router doesn't know any route to that.
Lens done. Good.
Yeah, I don't have any IP address here. Sorry, route here. So I don't have any route to this particular destination. So it is not able to come up. And now when I give route to that, route 1 minute, 0. And you can see immediately my interface tunnel will come up. My interface tunnel has come up. Now R1 doesn't know anything about the tunnel. Now I'll be going to R2. Hmm, 15.5. Now I need to mention the route. Now see, show IP route. My tunnel interface has come up, tunnel network. Clear? Now, 5.5.5.5, 25.5, or else I will mention here tunnel 0. My phi network is a static one. It has formed with tunnel 0, right? On R1, or let me go on R5, 2.2.2.2. I have the network 2.2.2.2 static route. On R2, I have 5.5.5.5. But on R1, which is in between, I don't have any network information 2.2.2.2 or 5.5.5.5. Clear? Are clear? Ping 5.5.5.5. My communication is happening, right? It will check whenever I have received the packet. My router has checked. It has to go to 5.5.5.5. What is exit interface? Tunnel 0. If I want to get out of tunnel 0, what is my tunnel source? Right? It will be this. Sorry, 12.2. It has encapsulated that with 193.162.12.2, whatever the ICMP packet I have received on that 12.2 as a source, and separate destination as 192.163.162.15.5. Now these are when he doesn't know what is inside of his ICMP. 2.2, 5.5, he don't know. Why? Because he's taking only this upper IP header. Clear? And the routing is completely dependent on this. Clear? And upon this, you can even run many other routing protocols, CHRP, OSPF, whatever you want. But remember that should be done with the tunnel interface IP. Clear? Let me do one thing. Let me just remove this. And even on R5, show section. Remove this. I remove this. I don't have any information regarding 2.2.2 on R5. Regarding 5.5.5 on R2. Router RIP. Network 25.0. Network 2.2.2.0. Immediately I have learned 2.2.2.2 via 25 to via tunnel 0. Right? The general way you run routing EHRP, OSPF, the same thing you can run on the interface tunnel also. Right? But what is the command I have given? Network 25. Why? Because the tunnel in network is completely 25 network I have configured. Right? Even the EHRP and OSPF also for the neighborship, they will use interface tunnel IP address as a source and destination. Clear? So this is your GRE, right? And if you want to configure multi-hop interface tunnel 0, no tunnel destination, and you need to give this command tunnel mode GRE multi-point. Here. And how do you enable NHRP? Network ID 1234. That's it. And on the spoke, how do you do it? NHRP. You need to just enable the network ID here. And you need to mention the IP address of the tunnel. And if you see here on R5, he will become the show IP dynamic. Sure. And you can see here immediately an entry is made. Clear tunnel source and tunnel destination. Dynamically a map is done. If he wants to go to 25.2, he has to encapsulate that with the address for 12.2. Still he has that ping 2.2.2.2. He's able to communicate. You're getting it? This is a multi-point. Now even I can bring this R1 and I can do it. Yep. So what did I do? Show run interface tunnel 0. What is the extra thing I have done on this? I have enabled NHRP here with network ID. Network ID, that can be anything. It is just a number, right? That doesn't don't need to match also on both the routers, right? Just it's a random number, you have to give it that, right? What you have to done, you have to just tunnel mode GRE multi-point, you have done it, and you have told what is a network ID. And on spoke, you have told source and destination, which will become point to point, and then you have told what is the network ID and to where should it register. That's it. Your multi-point will be created. Clear? So this is how GRE tunnel will be working. Clear? So with this, our VPN will be finished, right? And you can go for lunch, and you can come back up. Now what's the time? Here the time is. You can come back at 2:30, right? And after 2:30, we'll be continuing with IPv6, right?